code for my Twitch stream, and then game we're going to call replicating Wordle in Elm. Sounds good. So as mentioned, if you're joining right now, just say hello, say hi, say goodbye. I don't know. Say something in the chat, something nice, please. And if you have any questions of what I'm going to do, or you have some requirements you want to add to the app on the fly, I will try to do my best, and we'll see how it goes. So let's create the repo. I'm using my parcel template as I've mentioned. We're going to start from absolute scratch. Okay, so now I'm going to go to dev, git clone this new project, and then code Elm Wordle Twitch. So I can close this one and hopefully open this one. Okay. So now I can just run yarn. We'll get the project starting in a browser and we'll start doing things, if that's okay. Okay, let's start the server. And we're going to have the Elm file opened, which is the only thing we need. Localhost. Okay. So we have our Elm counter. Let me see if we are alone or something. And I don't know. I know I'm not alone, but I just want to check just in case. Channel. Okay, 3 people. That's fair. That's enough for me. So if you've never opened an Elm app before, it's pretty simple. This one is just a counter. I've added Tailwind recently because I fell in love with Tailwind, and I just noticed that I cannot live without it. So I said, oh, I might as well add Tailwind to my parcel template. And probably I'm the only person using my parcel template on GitHub, so it's okay. So let's just do a couple of things just to clean these. We're going to put the main here. We're going to say this is like some kind of Elm OCD. This is going to be the model section code. Then I want the view to live here. And then I'm going to have the update code here. Great. So let's think, what do we want the model to be? Then we will think about the message of the app. One disclaimer, we're not exactly replicating Wordle 100%. I mean, we are doing Wordle, but it's an MVP. It's the most minimal viable product. So we're doing a Wordle that kind of works, but that will have tons of user validation and improvements to do, or some other things. Okay, but bear with me, and maybe we can do them as part of the stream too. So what is our model going to be? This is kind of interesting. So first we need a solution to live in the model. We're going to have a current attempt, so to speak, and this is going to be an array of string. I need to import array. Let's see if Visual Studio Code decides to work correctly today. And then we're going to have the state of the game, which is going to be an array of arrays. We are going with the most naive approach possible, and if it works, it works, and if we need something more difficult, we will probably change it, okay? So this is the model we're going to work right now. And now we need to initialize this. And what do you want, Chad, the solution to be? I will let you decide the solution. Okay. So if you want your favorite word to appear on the Wordle, is your moment to say something now. Array, initialize, and it's going to be, it has 5 letters because Wordle has 5 letters, and it's going to be always empty string for now. And if you remember, we want to represent the state of the game as a list of as a matrix. So it would be an array of arrays. So we will have 5 columns, because that's the number of letters, and 6 rows, which are the number of attempts you get in Wordle before it tells you, okay, you couldn't guess it at the proper time. So we're going to first start with the initialization of this, and we will do this. And we're going to start doing something a bit funky. We want to initialize it to the empty tuple. No, okay, let's just do an empty string, and that will work. Should work, right? What did I do wrong? Okay. Oh, do I need another always here? Yeah, probably. Okay, perfect. So now we have our initialization, and I will show you exactly what we're doing as soon as I fix the code. For now, we are not going to do anything with this, or do we, or are we? Okay, let's destruct from here the solution, the current attempt, and the state of the game. And for now, we're just going to print here what we have right now in the state, even though it will look very, very crappy. So debug dot to string, the state of the game, this should work. And now these actions are not going to modify the model, they're just going to return it. And we want to see our app again. Great. So now we're seeing things, right? And now we will try to improve what we're actually seeing. Any questions so far? If you have any questions, feel free to ping me on the chat and ask me things. Okay, no questions so far. That's great. So let's continue. Oh no, what did I do? Okay. So we're going to start representing our state in a more, in a nicer way. English is silly. And let's see what happens. So we have a div here that it's basically centered in the middle. We have another grid here, which kind of works okay. And then we're going to do the following. We're going to have a div here, and we're going to say, take the state, array, turn it into a list to make it easier for us to work with. And then we're going to say list.map array dot, let's try map for now. We're going to call a function called viewTile, and then turn it into list again. And let's define viewTile. So viewTile, for now, it's going to take a string and return some HTML of a message. And we can just ignore for the rest of the stream, stupid Copilot, which absolutely does not work for Elm. And let's see what happens. So we want to have, what do we want the cell to be? For now, let's just say that we want an HTML input and the attributes.value is going to be the string, and we need to, all right, yeah. Do we? Okay. Expected a list of HTML message, but got a list of lists. Yes. So since we are working with a matrix, obviously we have a list inside of a list, an array inside of array. And what we're going to do is, since we're going to represent it just as squares in the screen, we can fake that we are keeping the grid state in our UI, just using gridbox. That's what we're going to do. It sounds crappy, but it's okay for this example. And we're just going to ignore this and do the stuff, you know? We're going to do concat map. Okay, and this should work. So now we're seeing the cells that we want. Great. They're not centered, which gets me a little scared, but that's okay for now. So now let's add some code to this to make it look a bit nicer. Attributes.class. We are going to add some Tailwind magic. So first things first, we don't need these. And here we're going to do more Tailwind magic. We're going to say with 50 grid calls 5 and gap 2. On our input, it's going to look like, let me see. Okay. W8, this is the width of each field. We want this to be uppercase, text center, and outline none, and border black. Let's see what this does. Okay, yeah, so we need to separate the styles of the div and put the input inside. Okay. This is going to be something very similar. Actually, no. Did I just miss border? Let's try. Maybe we don't need this wrapper. Oh, we don't even need this wrapper. Nice. So this is an improvement. Great. Or is it? Yeah, no, it's okay. Okay. So now we have the pieces of our Wordle, which looks a bit small. Maybe we can make it a bit bigger. Oh, it's not making it bigger. Nice. Well, how good are your eyes? Are you going to have, do you have any sight problems? I hope not. It looks quite small. And let me see if I can change the size, the zoom. Oh no. No, go back, don't do that. I hate you, Chrome. Why did you do that? Anyway. So for some reason, Chrome is not letting me zoom in. And that means that it's time to switch to Safari. Yay! Let's see if this works. Yes, it works. Nice. So sorry, Chrome. We're not going to use you for this stream. Okay, so we can hide this now. And now we need to think with the actual core of the game, so to speak, is what is Wordle? How does it work? How are we going to represent what happens? And if you remember sort of more or less what it looks like, it's okay, this is the Spanish version, but it doesn't matter. So you fill it with words, and then if it's correct, you will have, like in green, that you have guessed correctly a letter and the position of that letter. If the word contains that letter, it will, but you miss the position, then you will have a yellow background. And if you miss completely and the word does not contain that letter, you will have a gray background. So how do we represent that in Elm? Well, I'm glad you asked, with a custom type. So let's define that. Type tile is either an empty tile or an incorrect tile, and it contains a char, or a present. I accept name suggestions, chat. How would you call a char that it's present but you fail the position? It's a present tile. Let's call that for now. That's the good things. That's one of the good things about mob programming, right? That if people is watching you code, they can help you with the hard stuff, which is naming things. And then a cell that it's correct, it will be correct. Great. So now we are going, okay, we are going to need the number of attempts, which is going to be an int. And we're going to say that the number of attempts for now is 1. And we will later use that now. Okay, so now we can say that instead of an array of strings, our game is actually an array of arrays, or a matrix of tiles. Great. And what is it? Well, initially it's an array of empty tiles, right? Yes. And now this complains because our viewTile function is expecting a string, and now we change it into a tile. But this is what we wanted. So let's say tile. Now we can pattern match on this. Case tile of. If it's the empty tile, it's going to be what we have here. If it's a present tile and a char, it's going to be a different thing. So it's going to be, and this is some random templating stuff. We want it to be W9, border black, text center, text white, background yellow. Do I know how to spell yellow? Probably not. And then the content of this is going to be HTML text, and we need to turn the char into a string. String from char, very handy Elm functions. And okay, Elm doesn't like our indentation. Still doesn't like it. Okay, still doesn't like it. Oh, this looks like Haskell. Come on. Okay. And for now, let's say that we're going to have incorrect char. It's going to look exactly the same. And the correct, it's going to look the same. Present, incorrect. Okay. And now the input value, it's going to be empty because we don't want nothing to appear here. Oh, actually, no, we want. Okay, let's put empty for now. Okay, let's see what happens. So now we have a matrix of inputs that just look like a matrix because we're using grid and Tailwind, which is nice. And then if you notice, we can actually, yes. Okay, we can write Japanese here inside. Okay, let's change keywords again. And we can type one letter on each thing. Great. And now let me fix something because actually this is, I would say, gray 700, gray 800, gray 900, right? Because Wordle is not actually gray. Yeah, it's kind of gray, but it's okay. So we're going to use this. I can barely see this. Why do you do this to me, Tailwind? I need a darker gray. Any questions so far? Any things that you want to comment? Just feel free to do them. Text, color, no, border color. And if you have any questions, just post them on the chat and I'll try to answer to the best of my ability. Great. Wow, sometimes Safari takes a long time for some reason. Opening Tailwind docs. Okay, so I think actually we can kind of survive, right? What happens if we do this? Oh, this is too close. Gap 1. No gap. Okay, yeah, gap 1 looks nice. Oh, come on. Just work. Text color. I just want text color. There you go. Okay, no, yeah, this doesn't like me. Okay, yes. Slate. Oh, you call it slate. Gray. Ah, so it's gray. Oh my goodness. I will never understand English. So it's not gray, it's gray. This is American versus British English, you know, as always. Okay. 400? Kind of. Okay, looks good. And then we're going to put it here as well. And then if it's incorrect, this is going to be slate. If it's correct, it's going to be green. And if it's present, but you missed, it's going to be yellow. Okay. And now we need the num of attempts. So as you see very easily right now, like all the magic is in the viewTile function, which takes the types from this custom type. And depending of what we have, we are rendering different stuff. And then we have a bit of grid magic that tells us, displays this in columns, and we have a, a very easily starting grid for Tailwind, for Wordle. And I was watching the stream from Dan Abramov for some time, and he spent like 30 minutes trying to fix just the text center of the things, which was kind of sad. I mean, I know CSS sucks, but come on, you work as a front-end engineer at Facebook. You should know how to center text and an input, right? And then I said, okay, this guy doesn't know Tailwind. You will never code in you will never code in CSS again after this. Okay, and now here I want something that will look like a button with the text enter. Great. Do I want it that way? Yeah, why not? Okay. So let's make it look like a button. Rounded, background, slate. actually, I don't even know Tailwind. Background color, BG Slate. Oh, you need a number, yes. Slate 400. Oh, let's go back. Oh no, that looks terrible. Well, anyway, let's see. Padding 4. No. Well, or yes. Padding 3. Padding 2. Oh my goodness. Text white. And this is front-end development. We try things until they work. Great, so this looks like it's clickable. Okay, and this enter is going to do some stuff. So now we have kind of fixed or figured out the representation part of the game. And now obviously we needed to actually do something, right? Because if not, it's not a game if it doesn't do things. So the number of attempts is, we need it because we need to access by index the array in which we are. So if you remember the number of rows, it's going to be the number of attempts that we have, and the number of columns for which we need a different index is going to be the characters themselves. Right, so let's figure out what actions, what things need to happen in this application. Well, that I can think of, I could only come up with two things that need to happen. One is enter a character, and the second one is check if we have one, right? So let's do that. Let's do these two actions. We need type char, and we need the char that we want to type, and we need the position that the char has in the word, and we don't need the current attempt because we have that as the model, as the state, as part of the state of the application. And then the second action we need is that check word. Check word. Again, chat, help me with names. If you want to name some things differently, you are my guests today. So feel welcome and suggest variable names, type names. We might use them live. So this is something that you don't get to do when you watch a YouTube video. Great. So we're going to call this check word. And this complains because we are not using these two things. And check word and type character has the position and the character. Okay. So now, as you have noticed, we can write on these things, but we can, Elm doesn't know, nothing is happening on Elm side. This state lives on the browser, and this is a mistake, obviously. So we want Elm to know what is happening and to have in the state of the application in our Elm app to know what has been written. So let's rename this as events. And now what? Oh my goodness. What just happened? I think I'm going to leave Visual Studio Code very soon. Anyway, so let's see when we type a character, what needs to happen. Any ideas? Okay, so this is actually quite easy. If you remember, in our state, we had a current attempt, which is an array of strings. It should be an array of chars because it's really a word. Right? Okay. String uses double quotes, and I'm using a single quote. Okay, great. So what we modify while we type is this part of the state, the current attempt. And so we say that from the model, we want to edit the current attempt. Wow, this is going terribly. Of course, I don't have this in the model. Okay, thanks for the autocomplete. And then we're going to say array set. We need the position, and we're setting the char, and we need what was before, which is the previous state. Okay, and this will set the character inside the position of the array. Great, that makes complete sense. Or does it? Yes, it does. So where are we getting this position from? I will tell you in a sec. First, what is the thing that is going to trigger this action? The type char. Well, it's going to be this input, right? So we can remove this, probably, and say events.onInput, and then do something, and we're going to say input char, type char. Did we call it type char? Yes, type char. And the strange thing is about inputs in Elm is that their event, the only thing you can put into inputs are strings. So it's expecting a function that first expects a string and then returns a message. And this is our type character function actually expects a char. But first, before even getting the char, we need the int of the position. So we're going to have to pass the position here. And we're only going to use it in the empty things. And what is the char that we're getting? Yeah, position. Okay, and now this will complain. Okay, yeah, that butyl is not getting that int that it needs. And that's because we're just mapping, and what we need is to index map, which means that it's a map. It's like the map from ECMAScript that has as a second parameter, which is the index of a map of a list in JavaScript. Well, Elm has something like this. So instead of mapping the normal map, this will give you as a first parameter the integer. And now this is exactly what our function expects. First the int, then the tile, and then the new thing. So now we do have the tile, but we don't have the string that we want. The character, we have a string. So let's fix that first. We need to turn a string into just a character in Elm, which is no easy thing to do. Okay. Let's do it here. Okay, so you take a character, turn it into a list, take the head, and then if it's since head could be a maybe, we will default it to the empty string. We don't have actually the char here. We have this. We're going to turn this into a composition of functions because we can, and because Elm rocks, right? So this string to char function is something that, oh my goodness, takes a string and returns a char, and then before passing it to the message, we need string to char. Great. So if some of you got lost on the process, I can repeat that, or I can explain what's happening. What's happening basically right now is that on input takes a string, but we're going to only write a char. So now every time we type a word, A, C, D, E, if you notice, things are happening on the Elm side. And every time we type a word, so this is our current attempt, this is the state, as you see, is completely empty. The solution is ABC. You haven't given me a better solution yet. If you're not giving me a good solution on the chat, I will just put pizza again or something weird. And this is the current attempt. The reason why the current attempt needs to be an array and not a string will become obvious when we try to match if we have guessed the word correctly or not. So every time we type a char, as you see, so the state was completely empty, and then we typed A on the first checkbox, and then it updated this, and we typed E, then C, then D, then E, and we have our current attempt complete, and now we can try to do enter. So what is going to trigger the enter action? Well, obviously the enter button. That wasn't that difficult, right? So events, on click, and check word. Okay. But now check word needs to do some funny stuff. Let's go back to the update. So how do we check the word against the solution? So let's see. Any ideas? Any guesses? I think we're going to do it in less than an hour, which is great at this pace. Britis. I don't know who Britis is, but say hi if you're still on the chat. Well, let's continue. So we need to modify the model again, but we need to modify the state, and with the new state, and then we need to modify the number of attempts. And say model num of attempts +1, and we don't have this new state, but we do have the number of attempts. Okay, and how do we compute the new state? Well, let's do that in a let binding. So let new state equals blah blah blah. Great. And we need the current state and a modifier function. So we need the current state. Oh no, we need the current attempt. Okay, yeah, we want to map over the current attempt. Array dot index map. And then we need a function that takes, this is the index of the word and the char. We need to do something. And this will be the new state. Right? I guess so. So if the char equals array.get index from the solution array, from the solution, then it is a correct char. Else, if something, it will be a present char, and else of everything, it will be an incorrect char. Let's try and save and see what happens. Let's put a condition here. So if it's present, if string contains the model solution, and if we need the char, okay, Elm format doesn't like something. Else, why do you don't like my else? Oh, you should like it. Maybe it's the indentation. Shouldn't, right? Index solution. Okay, this is kind of weird. If but got stuck here in this else. Okay, so let's remove the if else for now. And we're just going to grade, find out if the chart is first correct or incorrect. So we compared using the index of the current solution and solution. Actually, do we do this? Yeah, because we need to compare on a string char at. No, there's no char at. Great. So we need to have a solution array. And the solution array is going to be model.solution string list, and then array from list, right? Great. And now we have an array of solutions that we can compare on a char by char basis. And now it says, okay, since get of a certain array can be a maybe, char is a string, we cannot compare a maybe with a string, but we can say this is just a string. Great. And now we can go back to this code and say, okay, something else needs to happen. Or does it? Then something else. I think, yes, we're missing a then. Oh, I'm so stupid. Yeah, Elm and Haskell have this problem. Great. So, and now a string contains this char, because char is a char. The solution is a string. Okay, so contains only works. It could be contains char, but it doesn't. And we need to say string from char, turn this into a string before we compare it. And now we can say if the char we're trying to guess from the word it's contained in the solution, then it's present. If it's correct, it won't go into here. And if we couldn't find it regardless, then it's an incorrect guess. Okay, so this is the new state, but this is the new state for the current try. So we need to update only the current attempt. So let's try and do that. Array dot set, and this takes the int, which is model dot number of attempts. Then we say I want this to be the new state on that position, and the previous state is state. Great. Let's try this out, and let's say, oh, let's have a workable solution first. What will happen? Actually, we don't, oh my goodness, we don't even need this. We just need the state here, do we? That's so lame. I mean, Yeah, so the solution is going to be, let's see, pizza. Can't think of 5-letter words. Twitch? Does Twitch have 5 letters? No. And which? Okay, yes, which does have 5 letters. Okay, great. So this is a bug that we we mentioned. We were going to make it bomb-proofing, but not really. I mean, we are sort of expecting that the users behave, at least in this first version, and they only type one character. Okay, so yeah, the word that we're going to try to guess, it's going to be which. Great. So now let's try it out. It's, let's say, A, C, D, E, F, enter. Okay, and the tiles that are incorrect are bigger for some reason. Okay, so let's try A, B, C, F, no, again, F, C. Okay, and now we see that everything is incorrect. Great. So first things first, let's actually try a word that contains E. And let's see if it works. Okay, why, if which contains I, why it's not working? Okay, because we are typing, if we have a look into Elm, we are typing, even though Tailwind is fooling us and we're turning everything we type here into uppercase, when we type, we are having lowercase and uppercase. So how do we fix this? Well, in the function where we type a character, we can insert another function intermediate, which is string.upper. And now, whenever we type something, it will actually be in uppercase. So we fix that. Now let's try and fix why this is bigger. I guess it's because I put W8 here. Great, that fixes it. I don't like the color of the present. I think it should be 7. Oh no, it's even worse. Okay, looks better now. And let's clean it up. And basically, Twitch. Okay, so yeah, all the words are here, all the letters are there, but we didn't guess the position correctly. And then let's try again. It contains this. Okay. Okay, we got the 3 letters right. And then this is something I need to remind myself of. If we finally guess the word correctly, everything will be green and we can be happy. So this is it. We have made it. This is like 40 minutes. We have made Wordle, a very basic version of it, but we need to improve it, obviously, because it has tons of flaws. Like in Wordle, if you try a word that does not exist, because Wordle has languages, then it will tell you, oh, this word is not in a dictionary. And what's the crappiest of all is that it doesn't go to a remote service and downloads a dictionary of 5-letter words. The application literally has hard-coded all the possible words that it accepts, and then it just checks, okay, this word that you tried is in my dictionary, in my list or not. If it doesn't, then it doesn't let you guess and you don't lose an attempt. So what happens if you run out of attempts? So we need to represent this in our UI somehow. And the place should be here. So let's see. Yes, here it is. So number of attempts, and we say if number of attempts is superior to 6, then we will show something, and if not, then the rest of the game. HTML div, HTML text, sorry, you lost, and we're going to add a sobbing face, and then say, okay, I don't know how to write. Let's put this h-full and see what happens. Okay. Okay. Last attempt that we have. Okay. And it did not work. Great. Are we actually updating the number of attempts? Yes, but this was our 6th attempt, right? Yes. Okay, then it's superior to 5. Yeah, okay, yeah, because we're starting in 0. Sorry, you lost. Yeah, I know. Okay, let's fix this. Grid, place, items, center. Great. So this is what happens if we lose. And if we won, we're going to do something else. I gotta go. Thank you so far. Thank you for coming. I hope you enjoyed it. So what I really wanted to do is a button that let you share your score. People are really hating this, but I like it. I mean, I like that you can share your progress, and we're going to turn that into a beautiful button. And as we finish that, we can go. So let's do that. How do we find out if we have won with the state that we have? So the solution, the current attempt. Okay, so we can compute if we have won already, right? So where do we have it? The solution, the chart into the solution. Okay, so we are going to calculate a function, and we're going to use it in the view, and we're going to say, have we won? And we need the current attempt. Have we won? Yes, so we want the solution. Yes, I know. So we want a string, then we want an array of char, and then we will say yes or no. Have we won? And then this will be the solution, this will be the current attempt, and we will say this, sort of. We'll say let solution array in solution, and we will say if solution array equals current attempt, then we have won. Or have we? Okay. Solution array is an array of char, and current attempt is an array. Okay. So solution is this. Solution is a string. Yes. If the solution array is equal to the current attempt, then we have won. So if we have one, we want to have a different button that does a different thing. Great. So now we need the solution and the current attempt. And we're going to say here if have we won solution current attempt, then we're going to show a button, and if not, a different button. And this button is going to say share. And now we need a third option, which is going to be we need a third message in our application, which is going to be share. Where is the message defined? Okay, but first I want to, what it needs to happen is we want to generate this beautiful emoji square with things. And what I wanted is that when you click on share, it goes to your clipboard. So we need to find out how to do that with Elm. And I noticed that we need to use ports. But let's do that because I don't think it's going to take us 10 minutes and it will make us feel very nice. So first, let's say share result. Great. And now when we click here, this is the button that will do the thing. And then we need a new thing that for now is going to return the model. And let's see how copy to clipboard in Elm. There's a Stack Overflow answer as always. And we need a port and we need some JavaScript. So let's open this, which is ready to have ports. If the target browser supports it, then you can copy it via ports. For example, okay, message is copy. If copy to clipboard, model copy. Okay. Oh, let's do that. It's easier than I thought. So let's say for the model, port copy. It's going to do this, CMD of message. We are going to say that we have ports, right? Great. And then we need to actually call the port. So let's try in the model. When we share the result, I think we need the result. Well, we don't need it because we have it in the state. We're going to say, oh, we need to return a message. Oh my goodness. Why do you do this to me? Anyway, because this is a side effect, this is considered a side effect. Great. So we will say this will do model and just copy, and this will do the things. So then for that, we need to turn this into an Elm app. Actually, we cannot use a sandbox anymore. We need to use an element. And then we need descriptions. And then this is always sub known. And we need to change a little bit the structure of our app. Great. So our init function needs to take some flags. Let's go to the init function. And then we're going to say flags, which we don't have, and we're going to return the model and a CMD of the message. Actually, can we just forget about the message? And we're going to say this is the model and this is CMD none. Great. And then the view needs to be updated. No, the update needs to be updated. The update function. So let's go to the update and let's say, okay, now we need a model and we need to compute. Again, CMD of a message. And then we say this doesn't have any side effect. And most of these things won't have side effects at all. Great. And now init says it should be, oh yeah, we have a parameter that we're not using. Great. So now we should call copy. And how does this work? How do we pass whatever we want to copy? Oh, so we have an input on a button copy. And can we say abs port subscribe? I want to pass it the string actually that I want you to copy. So let's do that. Let's just pass the string here. And let's say that when we copy, we say future solution. And we'll add a to-do here. Fix me. Great. So now let's actually do the code port. Const app is this app ports, copy, subscribe. And I want to get, how do we get information from ports in Elm? I forgot. Elm ports. Sending data to JavaScript. Ports. Sending data to JavaScript. Ports receive messages. Send event data. Okay, send message. Great. And then, subscribe. This is the message. All right. So this is the shared string. Okay. That was easier than I thought. And then we say copy. Query selector copy, execute command copy. Okay, how does execute command copy work? Let's see. Document.exec command copy. Interact with the clipboard. Oh. Read or write? Read text. Oh, write text. Okay, navigator.clipboard.write text. I think this is what I want, right? Yep, great. So this is great. This is exactly what I wanted. And then I want to also console log whatever is happening. And let's try this out. So we have things that we can close now. So whenever we win, this was which. Oh, we won without checking the game. Great. Okay, we click share. Something was done. And then if we copy, yes, we have the string future solution in our thing. Great. So the copy to clipboard is working, which is nice. Let's try and remove this to see if it still works. This is Oh, on an instance of clipboard. No, it doesn't work. Let's leave it as it was. Okay, and now what we want, well, we need to fix this first. So we can actually, we need to type enter. We need to first see that we have succeeded and then show the share button. So let's see how we're going to do that. Some people is actually hating that people are doing this. Okay, so the number of attempts is have we won? Have we won? Have we won? We need to find out if we have won after we have checked the word. Great. So we don't have any way of representing that here, I guess. Yeah, so one is full. It will start by, it's part of the state of the game. No one will win until we say so. And then we say, we don't need this function anymore. We will say, have we won? And when do we win? We win when we check the answer. It's crappy, but it will work. Okay. One, if the solution array is equals to the current attempt. Great. So now this will work, and we will turn our solution into the beautiful squares that we want. Great, so let's check this out. Okay, we failed. Let's now win. Okay, perfect. Now we have a congratulations message. If we won, we click it, and then we have in our clipboard the future solution. Okay, let's create now the graph that everyone loves. So we want a function that takes the thing into this. Actually, let's do it here. Solution to string. String. Okay. State string. It's going to be, for now, this. And then state string. And then we say model dot, we need model dot state to turn it into a string, and it's an array of arrays. So let's first turn it into our array.map. Each thing we are turning into array.map always x. We have an array of string of strings. And what am I doing? Okay. We want to map this, and then join string.join by empty lines. Okay. List array to list. Great. So now we have an array of strings. And now we need to do kind of like the same thing, but outside. No. Great. Let's see what happens now. What gets copied to our clipboard. So, which enter. Okay. And we have great. Oh, this is what we have, an array of x's. Yeah. So these ones need to be added, joined by spaces. Great. And the other one by new lines. Great. And now we need to map each tile, and we need to draw from tile to string, which is the nice thing that I wanted to do. So tile to string, it's going to take a tile and then return a string. And tile to string as debug.log, to do, implement this, and we're going to use this function here. Great, the types match, and this is perfect. Okay, so now let's do this. Tile, and let's say case tile. Well, let's use Visual Studio Code for this. Case tile of empty. We're going to return square. Where are the beautiful squares? The empty square is going to be this thing. The incorrect square is going to be green square. Actually, yeah, let's do it funny. Why don't we do it this way? Oh, this is incorrect, yeah. So this is going to be correct then. Incorrect is going to be another thing. Square, that I want it to be yellow, right? Yellow. Squares. There are no yellow squares? There are yellow squares. Okay, maybe we are not getting them filtered from here. Empty and incorrect are going to be the same. And present is going to be the thing that we wanted. So let's actually use max thing. Let's look for symbols or squares. Okay, here we have the color squares. And this is going to be the yellow. Great. So let's try a full Twitch account. Twitch. Pizza. Whoa. We haven't won. Great, 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 great. What happened now? Let's try to win it. Which... Great. So now we're writing to a different place. Okay, share it. And okay, yeah, the correct characters are a bit ugly. Yeah, that's why they're not using them. And let's look for a different square. The green one. Great. So yeah, this was a bug now. We can share it. It will be copied. And I think if we right now go to Twitter and we say, hey, we finished Wordle in Elm, we can paste it here and it works. Great. So the missing attempts, the rest of the attempts, actually, we don't want them. So let's fix that real quick. So before doing this, before mapping, let's say, oh yes, we want to array.filter if every attempt is empty, we want to filter it out. We want to filter the attempts that are empty, which means that we don't need them. And let's try that. What have I put here, by the way? Pizza, which Twitch, great. So we will filter the attempts that are different than empty, 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 array from list. Great. And now let's try again. Let's try and play again. Pizza. Okay. We guessed what? One. Then we say Twitch. We got them all almost right. And now we say finally which. And then we got it. We click it. Then we go to Twitter. This happening. Yes! It worked, and then we finished our Wordle. Let's put real quick a link to Twitch, to my Twitch. Okay. And then we're going to put this. And we have finished. We have finished our Wordle. So let's have a look at what code changed. This is just the port for the copy to clipboard. Very interesting. And if you have a look at the Elm code, this is the final state of our module. We needed to add this to the state, which is interesting. We needed to use a sandbox, an element, because we needed command messages instead of just the sandbox. We had 3 actions. One is to type the character. Another one is to share the result. This is the only thing that does a side effect, which is copy to the clipboard. Then we have the code that checks the word, and then we have a fully functioning kind of Wordle in less than 200 lines of Elm. So I hope you enjoy that. Thank you very much for staying and for helping. And well, I'm going to upload the code to GitHub real quick. Solve it. So that everyone that is interested in the code and that wants to check out this can do it. And it will be interesting for them. Okay, so it should say yes. 86% of the code is Elm, CSS is 1%, HTML is 6%, and 5% of JavaScript because of the port. So I see Martin saying something in the chat. Thank you very much. Glad you're here, and have a nice rest of the weekend, everyone. Thanks for coming.